Okay, so I got a great question. I think it was from Angela about the chi-square test and if we can do all of this work in StatCrunch. And the really good answer is that you can. I love when we can do things in StatCrunch. It saves us so much time. So first of all, we have here that we need to determine the chi-square test statistic, the degrees of freedom, the critical value using alpha at 0.05, and we need to test the hypothesis that alpha equals 0.05 as well. So we have a lot to do here. And the nice thing is they gave you this table over here, and when you have this nice little box, that means that we can open this in StatCrunch really easily. So I'm going to open this in StatCrunch, and we'll take a look at how we can have StatCrunch help us. So we're going to run two different things in StatCrunch. The first thing I'm going to run is actually the goodness of fit chi-square test, because that's going to give me both my test statistic and my degrees of freedom. Now the way that we do that is we go ahead and we press Stat, we go down to goodness of fit, and we choose the chi-square test. So Stat, goodness of fit, chi-square test. Now we have to just choose what we need here. So our observed column, they've already marked it observed for us, which is nice, so we'll change that. And my expected column is also, they already marked it expected. And now I just have to click compute. And voila, I have all my information here. We have our degrees of freedom is 3. Our chi-square test statistic is 0.95. And it also gives us our p-value, which we can use for our hypothesis test at the end. And that p-value is 0.8133. Okay, so that would mean that I can put in this, which I think Angela already got at 0.95, and our degrees of freedom is 3. Now the next thing I have to do is get my critical value. Now we had used, when we were doing the normal distribution, you could find your critical value, again, using StatCrunch, and we're going to do the same thing here. We just have to choose a few different options. So if you go to Stat, and we click Calculators, just like we did when we did the normal, we would have gone down. If this were the normal distribution, we'd be here. We're going to pick chi-square instead. And you can see now we have this really pretty graph of the chi-square, which is nicely right skewed. Okay, now we're going to change a few things here. We know now from our goodness of fit test that our degrees of freedom is 3, so we'll put that in. And remember that alpha is actually, in the chi-square distribution, it's the area to the right of your test statistic. So we're going to go ahead and, or the right of your critical value, I really should say. Got to get my words right here. So I'm going to change this less than to a greater than. And I want this little area at the end of the tail to be that alpha value, which is 0.05. So I'm going to put 0.05 there and click compute. So this critical value is the number 7.8147279. So that's that value right there where the area to the right under the curve is 0.05, which is our alpha. So I can go over here and I can say, I need to round to 3 decimal places, so 7.81, not 4, but 5, because it has a 7 next to it. And I got it right, yay. Okay, now we have to choose whether we should reject the null hypothesis or not. And there are 2 ways that you can decide to reject the null hypothesis. So I just want to show you in the text where you can find this in case you want to look at it again. So I'm just going to go to my e-text here. So this is on page 592 in 12.1, and this is one of the examples for conducting a goodness of fit test. But I always like to look at how they actually do it because that certainly helps me to really comprehend the information. So the way that they're looking ahead and going ahead and doing the hypothesis test here is they're comparing the test statistic to the critical value. And does that test statistic fall within the rejection region, which is where you have this shading happening? That's our area of 0.05. And in this case, that test statistic does not fall in the rejection region, so we do not reject the null hypothesis. So if I go back to my StatCrunch here, where'd it go? I lost it. Hello? Here it is. Okay, I found it. If I go back here, my test statistic is 0.95. So where is 0.95 in relation to 7.815? Well, it's somewhere way over here. So it's certainly not in our rejection region, so I'm not going to reject the null hypothesis. So if I were going to base my rejection off of that, I would choose one of the no's, so that's either A or C. And the reason is that our chi-square not, that's that chi-square 0, that little sub-zero, it's how we say it is not. So chi-square not, or initial, is less than our chi-square of 0.05. So that would be my answer there. Now, another way that they might ask you to make your decision to reject the null hypothesis or not is by the p-value. So remember, if the p is low, meaning lower than alpha, you reject the HO, or which we call H naught, right? So if the p is low, we reject the HO. So in this case, the p-value is 0.81. It's not less than 0.05. So if we were going to base our hypothesis test off of the p-value, we still would not reject the null hypothesis. Okay, so I hope that helps, and if anybody has any other issues with StatCrunch, please let me know, and I'd be happy to show you how to do any of your calculations here. Good luck!